Let's just get right to it. If you're a VLSI engineer and you don't really get system protocols, you are putting a hard ceiling on your career. It's really as simple as that. So in this explainer, we're going to lay out a crystal clear roadmap for understanding the essential protocols that, well, basically run the entire world of silicon.
The best way to think about it is this. Protocols are, quite literally, the language of silicon. Every single component on a chip, from the huge CPU cores and GPUs down to the tiniest little peripherals, they all communicate using a specific protocol. These are the rules of conversation that make everything work together.
And just like in the real world, if you don't speak the language, you can only get so far, right? Being fluent in these protocols is what separates an engineer who works on a small, isolated piece of the puzzle from someone who understands and can build or verify an entire system. And trust me, that system-level view is the absolute key to moving up.
Okay, so that's the big question, isn't it? How do you actually go from just knowing these things exist to becoming truly fluent? That is exactly what we're going to break down. We're going to cover what they are, where you'll find them, and most importantly, how to get a deep, intuitive mastery of them.
All right, let's dive in. We're starting at the bottom with the absolute bedrock, the protocols that make up the internal communication backbone of pretty much every system on chip out there today.
The very first name you have to burn into your brain is AMBA. It was developed by ARM, and it's not just one protocol. It's a whole family of them that basically act as the chip's central nervous system. I mean, if you want to understand how a CPU talks to memory or how peripherals get their instructions, your journey starts right here with AMBA.
Now, within that AMBA family, there are three main players you'll see everywhere. Think of AXI as the Ferrari. It's for your high-performance stuff, like connecting a CPU to memory, because it can juggle a ton of data requests all at once. Then you have AHP, which is more like a reliable workhorse for general-purpose tasks. And finally, APB. That's for the slow lane. It connects your simple, low-power peripherals where raw speed just isn't a big deal.
So once all the components inside the chip are talking to each other, the next absolutely critical link is to the outside world, specifically to the main system memory. This connection is almost always handled by the DDR protocol. This is the superhighway for data, the main artery connecting the chip to its brain.
And this is a great example of how things get specialized. You have standard DDR, which is all about one thing: maximum speed and throughput. You'll find it in servers and PCs. But then you have its cousin, LPDDR, low-power DDR. As the name suggests, it's built for mobile devices. It's totally focused on power-saving features like deep sleep modes, all to make your phone's battery last just a little bit longer.
So we've got the chip talking to itself, and we've got it talking to its main memory. So what's next? Well, now we have to look at how it communicates with everything else in the outside world.
If there's one high-speed external protocol that rules them all, it's got to be PCI Express, or PCIe. This thing is the king. It's the essential interface for anything that needs just massive amounts of bandwidth. We're talking graphics cards, lightning-fast NVMe storage drives, high-speed networking cards, you name it. And a deep understanding of PCIe, that directly translates to getting access to some of the highest-paying jobs in silicon.
You know when you save a photo or open an app on your smartphone and it feels instant? The reason for that speed is UFS. This is the main protocol for the fast internal flash storage in basically all modern mobile devices. It's the mobile version of that super speedy SSD you have in your laptop.
Ever wonder how a server in some giant data center talks to another server? Or, for that matter, how your home router works? Well, the answer is almost always Ethernet. It is the universal language of networking. Any chip that's designed for data centers or networking gear simply has to speak it fluently.
And finally, back in the mobile world, you have to know about MIPI. This is actually a whole suite of specialized protocols, but the two most famous are DSI, which sends all the image data to your phone's screen, and CSI, which brings the image data in from your phone's camera. They are absolutely critical for any mobile chip.
Okay, so here is the most crucial point of this whole thing. It is not enough to just know the names of these protocols. To really, truly advance your career, you have to go from just reading a spec sheet to getting a deep, intuitive understanding. So let's look at a method for doing exactly that.
Look, forget about just reading the spec from cover to cover. That's passive learning, and it won't get you very far. To really master a protocol, you have to get active. You've got to get your hands dirty. Break it down into its layers. Draw out the state machines by hand. Diagram the flow of different transactions. Even try to build a tiny little verification agent for it. Write assertions that check the rules. And my favorite, study real bugs that have been found in silicon. That's where the best lessons are hiding.
This single question,
This is the entire game. This is the mindset that separates a user from a master. You have to constantly be asking yourself, how can I break this? What weird corner case, what strange sequence of events is going to make this thing fail? That is the absolute core of a verification engineer's mind, and it's the fastest way to truly understand anything.
All right. I know we've covered a ton of ground, so let's pull it all together into a simple, actionable roadmap that you can start on today, especially if you're just starting out on this journey.
So please, don't try to learn everything at once. You'll just get overwhelmed. Start with the most important on-chip protocol, AXI. And don't just learn it, master it. Then, learn the simple but super common peripheral protocols, I2C and SPI. After that, get a really solid handle on the basics of DDR and PCI. And then finally, pick one of those high-speed protocols, like PCI or DDR, and just go deep. Use that active learning method we just talked about. I guarantee you, if you complete this roadmap, you'll be incredibly valuable and totally job-ready.
And really, that's the core takeaway here. When you master protocols, you stop just verifying little individual blocks. You start to understand entire systems. You see the big picture, how data flows, how the whole chip works together. And those system-level engineers, they're the ones who get to solve the hardest problems. And, let's be frank, they're the ones who are always paid more. So the only question left for you is, which one are you going to master first? The path is clear. Pick one from that roadmap and start your journey from just knowing about protocols to truly deeply understanding the language of silicon.